Okay. You are here in Montego room at JNation this year. So, good morning, good evening, good night. Where are you watching right now? So the whole point is we are really happy to be here to hold this conference online, where you can see people around the whole globe. But that's not about me, right? So let's talk about advanced test partners with Tankus.
All right.
So he's he's cool, even the name, right?
Oh, dude,
Tankus.
don't talk to my wife. She says I'm the most uncool person she's ever seen, and she still married me. So
You geek, I'll fasten the words. Board game is nice. What kind of board game do you enjoy?
Gloomhaven.
Oh, nice.
I got them little boxes right here.
Whoa, I can see.
Yeah,
Okay, I need to visit you as soon as possible because I enjoy this kind of thing.
yeah,
Comic books, and yes, programming. And today he will talk about advanced testing partners. So Tom,
yeah.
that's your stage is yours,
All right,
and
cool.
have a nice show.
Okay, thank you, Otavio. So I already got my introduction, so I'm just going to skip through these slides. So hi, everyone. I'm Tom Coles. It's unfortunately pronounced Coles and not Cools because, as I said, even my wife thinks I'm the most uncool person on the planet. So she calls me Derpy, which is not that good a thing. It's funny, but it's not that good. This is my website where the slides will be afterwards. And I work for a company, a consultancy company in the Netherlands and in Belgium. I am from the Belgian department. I've been working there for 8 years. Next to my work at InfoSupport, I'm also a coach at codingcoach.io. If you don't know it, it's a platform where they bring people who donate time, like me, coaches. They bring those people together with people that are looking for a coach. Like I'm a Java coach on the platform, and I've had the chance to coach people from Zambia, from Ghana, and it's a really nice experience. So if you were a Java developer and you have some spare time on your hands, definitely check it out and be a mentor and a coach on the platform. Next to that, I also co-founded the Antwerp Java user group recently. We're going into our summer holidays, but we hope to be back after the holidays again. So what I want to go through with you today is this. It's a beautiful day. You can see the sun is shining. It's a really relaxing morning. You wake up fully relaxed. You slept well. Your room temperature was just perfect. No mosquitoes. You can feel it's just an awesome day. But then you wake up and you realize, oh yeah, I'm on call today. Oh no. Your manager immediately comes in. What's going on? Monitoring is red, flashing red like some horrible movie. More calls arrive at the help desk. Help us. And then you realize that a bug caused some data corruption issue. So it turns from a magnificent, beautiful day very quickly into a bad day. Now, let's be honest, broken systems, bad, really bad. And I'm using bad. I had another word in there before, but I'm reducing my swearing. So broken systems, bad. So what can we do to actually avoid these broken systems? Well, we add more tests. So tests are kind of our safeguards to make sure that, well, no, not to make sure. I need to be very specific about this. Tests give us more certainty, not absolute certainty, that whatever we deploy into production will actually work. So the more tests you write, you might argue the better, but that's not always the case. Because honestly, we've been focusing a lot on the test pyramid, and I teach at university sometimes, and this is really presented as the be-all, end-all way of writing tests. And when people look at this pyramid and they think, oh yeah, so we have a lot of unit tests, and then a few service tests, and then fewer UI tests, and they really start to hyper-focus on the bottom part, unit tests, because they're fast, and a test set needs to be fast. Well, maybe this trade-off that we have here between they're faster, but they're more isolated, that's kind of expanding a bit. It's becoming a more difficult problem to solve, especially as the way we build systems is changing a bit. So tests can give you more certainty that something will work in production, but only if they're written in a good way. And unfortunately, I have a few examples of things that aren't written in such a good way. Because even if you have tests, it doesn't mean that because you know how to write the tests and you use these different test tools, that you apply them in a way that's actually valuable to your project. So the first thing I've seen in quite some teams is, oh yeah, but to make sure that we have enough tests and that they cover enough, we're going to just enforce 80% code coverage or more. Especially if a manager says this, it's a tricky situation. So I want to show you a simple program, well, a simple test, aptly named testing for coverage. So you can already imagine it's up to no good. And this is a simple POJO object. Well, it's actually a GPA object, but it's relatively simple. It has getters and so on. Nothing too big. And here you see a test that tests the getters. Hey, we have code coverage. Well, if you think about it, what does this code coverage actually mean? It means nothing because these are simple getters. There's no business logic executing here. So people spend time to write these kinds of tests often, but what's the value in it? And that's something that I really want to talk to you today about. What is the value of the tests we write? Because this gives us a lot of coverage. You know what also gives us a lot of coverage is the following test. I've actually seen something similar in the production code at some point. I couldn't copy that one for obvious NDA reasons, but I've seen this in production. Our manager told us to get X% of code coverage, so we just wrote tests. And one team even called it the cheap code coverage test. And what does that look like? Well, it just calls all the methods. And if you're really if you want to make yourself really popular, you put a try catch around it. And hey, if you run all these tests now and you run them for coverage, you will see that when this thing actually starts up, you will see that, hey, my class is well tested. I have enough code coverage, so that's a good thing. But as it turns out, it's actually not testing the things that are valuable about the class, because there are a few extra methods. And yeah, they're tested, but as you can see here, there's no assertions. It just calls it. So you have a lot of code coverage, but the code coverage doesn't mean anything. Now, one of the things that you could do to improve your tests that way, well, not that way, to avoid that people can do things like this, is to introduce a concept called mutation testing. And mutation testing is a concept whereby you actually change your production code and then you run your tests again. And if none of your tests fail, that means that your tests actually aren't good enough because none of the tests actually caught it. Now, there's a framework in Java that allows you to actually run mutation tests. So you don't have to change your production code manually or something. You have a framework that will check your production code and start changing around little things. So I'm going to run this one. It's called PyTest for Java. If you're not running Java, by the way, this is a little bit of an advertisement, so I'm sorry, but we were so excited at InfoSupport about mutation testing that we actually started creating our own mutation testing framework for JavaScript, C#, and maybe most importantly for the developers in this conference, Scala. So what are these mutations that we are talking about? So for example, you have different operators, so that are ways that you can change your code. And for example, this arithmetic operator will change in your code a plus to a minus. And then if none of your tests fail, that means that that specific piece of code actually wasn't covered correctly. So it was covered with tests. So your test coverage says, hey, we covered this. But when you start changing your code a little bit, you actually notice that your tests aren't failing. So your tests aren't actually testing something valuable. So this ran, I'll make it a little bit bigger because this says a couple of things. So it's my line coverage is not that good because this is an example project. It generated 119 different mutations. So it changed a plus into a minus. It put a false into true. It removed any kind of logic and just returned true if the method expects a Boolean return value. So it created 119 of those mutants and only 23 were killed. So killed means that they make a test fail. Now, what does this look like in a bit of a better format? Let me just, that's the new IDE. They changed the location of this thing. So it generates reports. That's maybe a bit too big. And if I go to my Velo station, you can see the 85% is there. So that's the line coverage. But when you check the mutation coverage, it's actually really highlighting that my tests aren't that good. So I have good code coverage, well, line coverage, but if you look at the mutation coverage, you actually notice that it's not that good at all. The good thing is about PyTest and also about the Striker framework I talked to you about is that it actually notifies you what kind of things are wrong about your code. So for example, let's look at this one. So what happened here is you can look at the comment, well, the pop-up that's coming, and it says it replaced the return value with an empty string because it's expecting a string, and none of the tests failed. So that mutation survived. So that actually highlights which pieces of your code are decently tested, even if they have code coverage, because even if they have code coverage, it could be that the code isn't covered in the way that you would actually want it to. And it has a lot of these. And one of the more interesting ones is that it actually complains that I've never tested the equals method. And this is a weird one because I've hardly ever seen anyone test their equals method directly. So this begs the question, should you test your equals method? Well, it's used for a lot of things, just like hash code is used for a hash map and such. So maybe you should test it. So that leads us actually to another piece of software that might help you actually achieve that. So we use mutation testing to discover which pieces of our code are tested but aren't tested in a good way, or even pieces of our code that aren't tested at all, so they should be taken care of a bit better. Now, for the equals and hash code, there's actually a framework as well called the EqualsVerifier. I don't know if anyone has, oh yeah, it's not interactive. I don't know if anyone has heard of this. Listening to crowd, no answer. Okay, then I'm assuming that you haven't heard of it yet. Where you can say, hey, I want to verify the equals method for a certain class. Now I had this one disabled, and the reason because this actually fails. So this will verify the equals method for my class Velo station. That's the class I was showing before. And you can see that it's giving an error. And let me just zoom in here a bit. EqualsVerifier found a problem with the equals significant fields. ID is marked with @ID. So, but the equals doesn't use it. Oh, so sorry. So the equals shouldn't use it, but it does. So there's two ways to approach GPA equals method because it's actually a GPA entity. So either you use a surrogate key, which means that you want the equals to actually work on the ID field, or you want to let it work on anything but the ID field. So if you don't like a warning, you can always disable it by suppressing the warning. There. Now, if I run my beautiful test again, well, I get a short drink because it's really warm in here. It's actually saying, hey, the equals method should not use lon, which is a field inside the class, because you're saying you want to use a surrogate key, but it is used in the equals method. So what we should do here, you actually learn a lot about how an equals should be implemented just by running this library for once. So it says this field is used in the equals, while I'm saying that this is a surrogate key. So the way I solve this is, yeah, I'm using a lombok, so I'm actually not that sorry to use lombok. I can actually say, hey, I only want the equals to work on the ID field. So now it will generate an equals only on the ID field. And if I run this test now, it actually passes. So now my equals method is implemented correctly. So this equals verifier, I know the developer and I've committed on it a couple of times. Jan is actually really nearly obsessive about implementing equals correctly. And the great thing is whenever, if you apply this in your code and you get an error message, it actually explains every error message and why that's an issue for your equals method. So that's a really good one to look into. Now those are really local changes. The mutation testing is to see the unit tests that I have, how can I improve them? And the equals verifier is to test, yeah, your equals and hash code methods. But, oh yeah, mutation testing. The slides will be afterwards for reference. Not a big deal. Then you see these kind of things. These are unit tests, but what we often see is people start mocking everything. And if you mock something, you're not mocking it. It's gonna mock you when it breaks in production. So what you see are classes like this. I actually have one here. So this is a typical, hey, I have a resource that calls a repository. I mock the repository, so I create a fake object for it. I say, hey, this repository is going to give back a list. I set it up, my mock, my object. When I get my stations, I want those same stations that I put in the mock again. So basically, you're not really testing anything. You're testing your mock, because if you look at this implementation, it's the repository that you mocked away. So you've basically created a tube, and you put a ping pong ball in one side, and then you check if the same ping pong ball came out the other side. And that's just not a valuable test. That's actually a shame, and it takes effort. People put a lot of effort into writing this. Look at all these lines you need for a test that actually isn't that valuable. So for the rest of the presentation, I want to look at some frameworks and tools that can actually improve those kind of tests and to mock less. The reason why we have to mock less is one of the reasons is because we're moving more and more into a microservice environment, where actually the real issues often don't happen anymore within the same runnable unit, but the issues more often happen in the communication between components. Because when you build people rage against monoliths, but when you have a monolith, at least it's one unit that you maybe can compile, or at least you can do more tests up front. So the way we're building code is actually just changing. So maybe we should look into ways to adopt and not mock everything away. So I actually should show you the application we're building first. So this is a full view. Come on, Plant2ML, work with me. Yes. So we're building a really simple service. In our control, we are going to have a database, which is not inside Spring. We have a Spring Boot service, which will be called through a REST API. And then that Spring Boot service calls another API. So we have both a database integration and an API integration. So we can't do all this in our tests, because then they're very fragile. Either the database needs to be available on every machine you want to run the tests, or the service needs to be available every time you run the tests, and that just is fragile. So we need to find a way to replicate these things as close as possible without really depending on them being there. So let's start with the database part. And the first thing a lot of developers do is, oh yeah, we'll just use H2. So for those of you who wouldn't know it, H2 is just an in-memory database. It looks like I have too many files. It looks like this. So you have the Spring Boot application. It has an in-memory database. So we no longer have a dependency on this extra database. We're really focusing on the databases for now. And it will create the tables automatically. So you don't actually have to worry about your database being ready, because it will be in the same process basically as your Spring Boot. That actually gives us an advantage, because now we can have the same tests that we had before, but instead of using mocks, we were actually first inserting all those entities into our database, and then we're verifying if we can get them out again. So we're testing a bit more. Instead of mocking everything and working only in Java, like our own libraries, we are now also testing the GPA code, so the mapping between our Java objects and a database. Oh, and it's already passed. So it actually starts up pretty fast, and there is a way to actually go check the console and see that everything works, but we're not really going to do that now. So the benefit of this is basically you have quicker tests. Well, not quicker tests, you still have quick tests, but they test more. They test your GPA logic and so on. And it creates the DLS automatically. So it creates your database tables and structure automatically. That last point is actually also a downside, because that doesn't mean that it assumes that your database in production will have the same structure, and there can be some differences, and that's where it can go wrong. Plus, it's not a real database. It's still an in-memory database. It works pretty well with GPA and such, but it's still not the real thing. So if you want special Postgres commands or something, that's just not going to work. So what's something that we can improve? So it's always a balance between how more accurate our tests become, usually how slower they become. So we're trying to balance here. And I think each of you, when you go back to your team, should try to figure out what's actually the right balance for your team. So what's actually next is to use Liquibase. And Liquibase, for those of you who don't know it, is actually a way to run database scripts when your application is starting. Well, that's how it works in Spring. It's a database migration and database schema management tool. So how does our picture look now? So we still have Spring Boot. We still have our in-memory database, so the H2 remains. But we now have Liquibase, which will create the tables on startup. So how do we define what it needs to start up? Well, we have a change log here with different migrations. And we have a definition of how Liquibase should add these, how Liquibase should, I have to phrase that correctly. This defines what changes Liquibase needs to execute, and Liquibase will translate these kind of files into actual queries on the database you're talking to. So it has some preconditions just so you can skip certain changes. But now you have a change set, you have an order, and then you have changes. In this case, I'm going to create the Velo station table. So the table that was backed by the JPA entity we discussed before. It has some constraints. And I added a constraint here for the name, because in the previous example, without Liquibase, it's actually a bit more difficult to have all constraints in one place where they will be able to be used by both your tests in H2 and the real database. Because if you deploy this to the real database, let's say it's a MariaDB database, Liquibase will still use these files to execute them against the MariaDB database. So it will still create those tables, but it can add constraints. So constraints are now an option to be added in our tests. So that actually leads us to something pretty interesting, because I added a constraint that if I didn't supply a name now, so basically this test is just the same as the previous one. Let that just run for a second. So it takes a bit longer now. So that's the trade-off. Slower tests, more accuracy. But what it is saying now is could not execute statements, blah, blah, blah. Constraint violation could not execute statement. And why couldn't it execute? Null, not allowed for column name. So that's exactly what the constraint was that we added in our table. So this you can't easily do in a convenient way with H2 itself, especially not if you want to run it on the real production database as well. So what does it actually look like? Because we can go, if I debug this one, oh, I put it on a thread. Give it a second to boot up. You can actually see in the change log, oh, it's jumping all over the place. You can actually see in the change, in the logging, that it's executing certain files and who wrote the file. So that's always convenient to blame someone. Let me just have a look-see at the database, and this one should work. There we go. So this is what Liquibase does. It has created this Velo station table where the constraint is now available. That's great. And it's created these tables to basically manage which of their migration scripts have already run. So these are internal tables that Liquibase uses to manage which scripts have a run and which haven't a run and so on. So that's Liquibase. So the extra layer we get here, let me just stop this one. The extra layer we get here is that your tests are still relatively quick because it's still using the in-memory database, but your database setup is the same as in production. Well, it uses the same migration tool. So you can use constraints, you can use foreign keys, and so on. So the downside is that you saw that the startup is already a bit slower. So that's because the database needs to be constructed. So Liquibase needs to have a chance to run. So that's, again, the trade-off. We go a bit slower, but it's more correct. For me and the teams that I've worked with, this usually is the sweet spot for faster integration tests, because it has some constraints that are enabled now, but it's still the faster H2 database. Now, when I say this is the sweet spot, that was until like a year or a year and a half ago, because then something became really popular, and that's test containers. So what is test containers? If you know about Docker, which you probably should know by now, well, wouldn't it be nice if someone could create a framework or whatever that starts a specific Docker container like this with the database that you actually use in production. So you start it up, so it's not inside the Spring Boot, but it's inside your control. So if for a test, they could spin up a quick Docker container, and then afterwards it would just kill it. And that's exactly what test containers can give us. So in our example, we're still going to use Liquibase to provision the database, but we are going to use a real PostgreSQL database now. So that's this one. What does that look like? Well, I'm using JUnit 5 is important to mention because the annotations and how you set this up is a little bit different. So I have a PostgreSQL container. This is a special module within test containers with a specific image name, so you can even change the version up a little bit. I give the database a name, the user password, and then I need to tell Spring, because Spring needs to know where is this Docker container, because this Docker container will basically start on a random port that's available. Luckily, this class that test container provides gives you a convenient method to return the GDBC URL and the password and the user. So that's actually quite convenient. The rest of the test is still the same. So if we start this one, you'll see that we once again will have the trade-off. We'll go a bit slower because now it actually, not only does it need to start Spring and run Liquibase, it also needs to start a Docker container for this. So if we're lucky, you can see the cute little Docker whale is here. So it's even logging a few of the things that your Docker is doing in the background. So this actually starts, well, it creates a container for an image. It actually starts it up, blah, blah, blah. Runs my tests, executes the Liquibase again. The change set is here. Runs the tests, so this one, and then it closes down test containers again. So this is, for our teams now, really the way to go for testing. Yes, it's a little bit slower, but you are testing against the real database now. So you get very accurate performance. Well, it's still on your machine, but it's the best you're going to have on your machine, given everything. Docker doesn't add that much of a performance issue. The database setup will be the same as in production, basically. So you're using the same database, you're using your Liquibase to provision it automatically. So this is probably the closest you're going to get besides downloading dumps from production and provisioning it that way. So trade-offs, and I think these are well worth it. They're the slower startup time again, because as I said, Spring, Liquibase, Docker. It's worth it. But it also requires additional data to be, additional software to be installed. So the software actually isn't that much of an issue because I think most developer machines have Docker in some way or another, but that's something to keep in mind. Yeah, that's it for databases basically. So we've managed to improve our database connection in our flow a bit. So we can now test with a lot of certainty that it actually will work. So now let's look into the API, because we also had this. Let me just get back here, this API here. So now we've tested this we're going to do with test containers. This one, that can be a bit more tricky. So let's look into how we can actually avoid mocking this REST client or whatever you're used to. And let's just see how we can test this as well as we can. So the first thing we can do is use test containers. Hey, big surprise. So what you can do, I'll just scroll down a bit. If you have it, is you can just create your own test container. So if you know a bit about Docker, you know that if you have a resource file, like here, you have a Docker file and a JSON next to it with like stub data, then you can actually create a really simple, let me just zoom in a bit. You can create a really simple Docker container that will return you some stub answers. So you can actually, with this test container framework, you can also make a generic container. Then you can do basically whatever that you can do with Docker. And you say, hey, I want to use it from the class path and just take everything in the directory being the available test container. So then it will actually build a container for this and deploy it. Then you use the IP and the port to actually connect to it in Spring. So that's the URL that you're registering with Spring. Let me just quickly run it because I need to drink because it's really warm in here. There, I don't know if it's clear in the logs, but here it's saying, well, your typical Docker commands like, hey, I'm copying this file to the container. I'm downloading, I'm running the endpoint command. So you can really see that it's building up everything here. I'm not going to go through it too much. So what we have here is we have our API, our service, and now we've Dockerized the external service that we want to use. Now, if you have, if you're integrating with a team that also uses Docker and they have a really simple application, then it could technically be possible that you just get their Docker container and use that, but that's not always possible, unfortunately. So if you have the capability to do that anyway, it's pretty accurate for testing. And if you use, this is a big if you use the Docker container that another team is making, so the other application, then it's easy to maintain changes of the API because you're basically running the other API inside the test container. That's not always the case. So the big downside of this one is availability of the API in a Docker container. Maybe it's not even there. So if you don't have it Dockerized somehow, then you can't actually use it. And that's also a problem if the other application that you're trying to boot up has transient dependencies. So if that application also depends on a database, then it ends up in an entire big ball of messy Docker containers that you would have to start up. And then it's probably better to look for another solution. Maybe something like WireMock. So WireMock is a testing tool that allows you, I think it's this one. Oh, I'll just show this. So instead of having the real API, you're going to have a WireMock. I know I said that we were going to remove mocks, which is why this framework is named a bit unfortunate. But the main argument that we have here is we really want to test the REST client going to another service and that your mapping works. So the JSON and Java mapping, so going from Java to JSON for the post or the requests, and when the response comes back, that it can transform that JSON back into a Java class. So that's what we want to test, and that's something we can still achieve with WireMock. So what does WireMock look like? When I just focus on this one, you get an object. How you set it up is a bit different, so I'm not going to focus on that too much, depending on your test setup. So you can basically say, hey, I want to stop when I get a get on the root of my API. I just want to get an empty list. So that's the one to retrieve the stations. So then I just want to verify, hey, is this list empty? So what happens here is it will start a WireMock server on a different, either on the same machine or on a different machine, depends on your setup. I think I set it up that it's actually on the same machine, but on a different port. So it starts up and your test succeeds. So I now called a WireMock server because I first set it up to give back an empty array. Now that's a simple one. When it gets a bit more complex, you don't want to put a lot of big JSON in here. So what you can do is say, hey, I have a file somewhere in my resources, which by convention is __ file. And I have my data in there. And just when you call this, just give me the available data back. So just read this JSON and return that. I have a simple test, has size 2. That's because this guy actually has 2 JSON entries here. So you can run this and yeah, it'll just spin up a new service and so on. So you can even do a bit more fancy stuff like having delays in there. So you can test for a little bit of resilience, but I'm not going to go too deep into that because this, you can already feel like this is a management hell, keeping these JSON files up to date. And what if the API changes and it's a bit of a mess? So one of the things you can do instead of like copy pasting a ton of files is it actually comes with a recorder. So here I'm saying, remove my mappings, start recording. This is the real API, by the way, where you can get all the data of all the rental bikes in Antwerp. It's not protected, so you can use it for free. I've been using it and they haven't found me yet. So you start recording, you call the method, so it actually proxies through. Then you will stop recording, and then it will fill those recordings. So let me just, no, I'm not going to run it. It actually puts those recordings into these mapping files. And these are just WireMock files that contain the definition of what a certain request response should be. So this is at some point in time the actual answer. As you can see, you don't want to copy paste this manually for eternity. So it can record this, and then you can use those recordings in your tests. And it does that automatically because it anything that's in your resources mappings folder, it picks up without you actually having to do anything. So here I don't set up anything in WireMock, and I can still retrieve the stations. So we have WireMock, so that's a bit easier to configure. You have recording functionality, and it has options for some simple network issues. But you still have an issue because you can record, but the synchronization, I don't know if you saw it, but the recorder here, I disabled the tests because it's a manual one, because you don't want to call, we set that in our tests, we don't want to depend on the real API. So you can't actually put this in your test set without disabling it, because then it's talking to the real API again. So you actually need to disable it and do this manually, unless if you want your tests to fail if the other API is not available. And it often doesn't include all the request details, because if you look at this test, this one will not have any of the headers, authentication, or things that the real API might have. So it's not as complete as you might want it. That brings us to the last topic of today, and that's test by contract. So there's this new concept called contract testing, where it's actually quite cool, and I've having a lot of fun with it in our teams recently, where you, instead of writing a lot of tests yourself, you define a contract. And the contract is really between someone who's going to use your API and you as the API producer, or maybe someone else as the producer and you as the consumer. So you design a contract. What does a contract look like? You can make it in Groovy. There's a few different formats, and this specific one is the Spring Cloud Contract Framework. I'll have all references on my website so you can investigate it a bit further later. So what does this say? Hey, we'll make a contract, and I'm saying, I'm giving it a name just for readability in tests and such. When I do a GET request to /velo and then a number to get the details of a certain station, for example, this one, then I want as a response a JSON as an application as the content type, and in my body I want these fields, and they need to follow these parameters. Now, if you write such an, let me just show you the Java example. It's not. I'll leave it up to you what you find more readable, but honestly, being a bit more of a Groovy fan here. The great thing about this is you agree to this contract with two parties, a consumer and a producer. Now, you actually both need different things, because as soon as you have the contract, the producer wants to start building his API, but the consumer actually also wants to consume the API that's not written yet. So you have a bit of a problem, but we can solve that. From the producer side, we can automatically generate tests for this contract to validate if the API complies to the contract. So let me just pick that up here. There is a nice Spring Cloud contract plugin for, no, it's this one, to actually convert these classes or Groovy files into tests for the producer. So then the producer can run these tests to verify if his or her API actually complies with the contract that you've agreed. It actually says, hey, I found these contracts. It created this file, and this is a test that's generated based on the contract. And actually, I must admit, when I first saw it, it looks pretty good for an automatically generated test. So it tests, I actually have 3 contracts here. So let me just go to this one. This was the more complete one. And this one will run against your application. So if you need to set up things, the great thing about this framework is you can actually make sure that it extends one of your classes. So this is a class that I wrote. So that's basically to start up Spring, set up some things, whatever I want. And it created a class that extends this class. So that gives you a lot of flexibility of what you actually need to set up and run these tests. How do you do that? Well, it's pretty simple. Just some Maven where you Maven file where you say, hey, by the way, I have a few base classes that I want to use, that I want you to use to generate those test files. By the way, here they are. And then it will use those. So that one is in here, and I have a base folder. So that's for the producer side. So that's pretty cool. You have tests that generated, but from the consumer perspective, I want to start working as quickly as possible. And maybe you saw it already, but you can also generate stubs from that application. From that contract. So then it actually generates a jar file with stubs, and this just contains basically the WireMock files. So these are just WireMock files. And then when you want to start using it, either you run the jar, or you have this nice annotation in the Spring ecosystem, let's say, where it will find a jar file inside your Maven repository. So either your local M2 Maven repository, or it can also be a remote Maven repository, Artifactory, whatever. And this is saying, hey, get me those stubs, so this jar file, and run it as a WireMock server on this port. So I have a really simple test here. That's just, hey, connect to this thing, and let's go. And normally, if everything goes correctly, you can see that it resolved. Well, you can't really see it because it's pretty small. It actually resolved the artifact. That works. It's actually seeing which things are mapped here. So ping, health, and here is the one that's mapped. It starts up a WireMock server, so the thing we saw before, and then it just runs your tests. So by writing these contracts, it's really powerful because you get both the tests for the producer and on your consumer side, you get your stubs. So awesome. So contract testing, it actually encourages upfront design because you first make the contract and make sure that you collaborate with the parties that are involved. It can generate both the tests and the stubs, which is awesome because once you have the contract, you generate everything and you can just start building until green. And there's a few different ways to collaborate. So either you can have the consumer give you as a producer the contracts. There's a lot of different ways to work together here, but I'm not going into too much detail for this session. It's a bit of a complex setup, and actually both producers and consumers need to agree to work like this. But once you get everyone in agreeal, or even if you have a front-end team that wants to work faster and you do it that way to have a contract between your front-end team and your back-end team, these are good use cases where you could use contract testing. So if you want to learn more about contract testing, because I went a bit fast, tomorrow at the Bucharest Software Craftsmanship Group, that's the one hosted by Victor and Thea, there is actually a full session on contract testing. So if you're more interested in how this could work, then be sure to check that out. So to conclude my session, you're on call today. Everything just goes horribly wrong. You don't want those days. You want to avoid those days. So be careful when you think back about the testing pyramid. Yes, unit tests have their use, but the way it's written like this, they seem overpowered. Like you have to write too many of them. Always be careful and check. It's not because this pyramid works for some teams that maybe because you have a very integrated system, maybe it's better for your team to have more integration, a bit slower tests, but tests that are really accurate. So what I really want to ask you to do today, well, not today because it's already late, but maybe tomorrow, is just have a look back, go home, sleep, and when you get back to the office tomorrow is look at your test and just see where you can improve them based on costs and benefits. Not just we need unit tests for everything, we need coverage, but are the time that we spent writing these tests, are they actually valuable enough to validate that time? And make sure that you're able to sleep at night, because that's what most of these tests are about. Just feeling confident in what you've written and that it's as accurate as possible given the trade-offs that you have to take. Now, my session is almost over, but actually there's two very related sessions right up, and you probably have to choose one because they're at the same time. So if you want to learn more about those test containers I talked about, Jonathan Villa is talking about them and how he used them at a project. So if you want to learn more about test containers, go to that session, I'd say. Then I talked a lot about avoiding the fact that they wake you up as a developer because something went wrong. But Tom Garnon actually will talk to you about the things you need that if something goes wrong and it couldn't be avoided by tests, how you can make sure that you get back to sleep as soon as possible again, because sleep is precious. So these are two sessions, choose wisely. So that's all I had for today. I would like to thank you very much for joining. The slides and everything will be available at this link. I'll tweet it out. So if you follow me on Twitter, you will find it. And then I'd like to thank you for being here. And I'm going to get an ice cold drink because I'm actually melting inside.